All right, welcome to our concept guide, sections 9.3 and 9.5, talking about arcs and angles within some circles. It's a really beautiful day, the sun's shining. I hope the glare makes the screen okay for you to see, but hopefully that doesn't create a problem here. But let's get right through this. All right, so we've been talking about some circles. We've got to define a couple of things. These are not hard definitions. The first thing we've got to define is this thing called a central angle. Central angle is an angle whose vertex is at the center of a circle. That should not be surprising here. So an example, angle BXY is a central angle. Why? Because the vertex is at the center. Can you find any others? Good. Angle AQX is one. That's right. Any of these other ones that you can name that have Q as the vertex, AQI or whatever, those are all called central angles. Now, an arc is a part of a circle, an unbroken part of a circle. So, for example, over here, this would be called arc XB. Start over here on X, move over to B. That is the arc of the circle, arc XB. So it's kind of like moving partway around the circle. Here's another one, arc BY, and yeah, there's all sorts of other ones here. There's arc AB and all sorts of things. So yeah, but that's what an arc is. It's part of the circle. Now, an important kind of a terminology here is that there's called major arcs and minor arcs. So there are two arcs that start at A and end at B. The one is the short one here, arc AB, the short way around. We call that the minor arc, the shorter one. And then we call the bigger one that goes all the long way around the circle. That would be a major arc. That's going to be arc AYB. So the major arc, we have to basically give it more instructions. If it just uses 2 letters, it's the short way around. If it uses 3 letters, you have to tell it that I want to go all the way around, A and then YB. So 3 letters for a major arc, 2 letters for a minor arc. One other thing that we need to talk about is a semicircle. If the endpoints of an arc are diameter, then the arc is called a semicircle. You know that word. It's half of a circle, semicircle. Okay? Now, arcs have measurements. I'm not talking about the length. I'm talking about the measurements, like angles. And so, oh yeah, if I'm going to name these semicircles, you'd use 3 letters because you have to tell which way to go around. If it starts at Y, ends at X, does it go this way around, YAX, or this way around, YBX? That's the reason you use 3. Okay, so the measure of an arc, this is where we get to the nitty-gritty of this. The measure of an arc, of a minor arc, is equal to the measure of the central angle. It's always going to be less than 180 degrees, okay? So over here, the measure of angle AB, well, this arc AB is intercepted by this angle AQB. So yeah, the angle AQB, the central angle AQB, intercepts this arc, because A and B, okay? All right, so what's the measure of this angle? AQB has a measure of 90 degrees, so does that arc. The measure of arc AB is equal to 90 degrees, just like the central angle is 90 degrees. The measure of the major arc, AYB, is going to be 360 minus. So I think you probably already know this idea that this 360 degrees goes all the way around the circle. So if AQB is 90 degrees, then the rest of the circle is going to be 180 minus that, which is 270 degrees in this case. All right, so a major arc and a minor arc together will add up to equal 360. So these questions end up being really not that bad. The measure of arc BC, arc BC is cut off by it's intercepted by angle BOC, whose measure is 32 degrees, so the measure of BC is 32 degrees. Measure of arc CBA starts here at C, and it goes through B, and it ends at A. Well, CA is a diameter. Therefore, this arc is a semicircle. It's half of the circle. 360 divided by 2 is 180. The measure of angle DOC is right here. It intercepts arc CD, which is equal to 58. Central angle equals the arc, so that is 58. The measure of arc BD, well, it's going to is that going to go the long way around or the short way around? Because it's only two letters, it's going to go the short way around. So we can just add those things together. 32 plus 58 gets us 90 degrees. So yeah, we can add those arcs just like that. DA is going to be the semicircle minus 58. This is a semicircle, that's 58, so DA is going to go the rest of the way around. So we can add and subtract these arcs. Measure of angle DOA is going to equal that arc. And then the measure of angle DBD, DBA is going to start at D, it's going to go through B and all the way to A. That's the major arc. So it's going to be either you can go 180 plus 58, or you could go 360 minus 122. If this arc here is 122, DBA is going to be that 360 minus 122. Okay, so a couple different ways you can get those. What I recommend that you do is you just fill in all of these things like this. And, well, not like that, never mind. You fill in all those things, and it'll help you out. So pause the video, see if you can answer 5 through 19 down here at the bottom of the page. I bet you can. Do a lot of them. Pause it. Do it. Seriously. All right, did you notice that these are congruent arcs, that this is a semicircle? So hopefully that helped you to figure that one out. Maybe. All right, here are our answers. And yeah, hopefully that got a lot of those things right. We'll see. Let's move on to the other thing. All right, an inscribed angle. Okay, an inscribed angle is not like a central arc, so it's not going to be equal to the angle, but it's also not going to be hard. An inscribed angle is an angle whose vertex is on the circle and whose sides are chords of the circle. So the difference is, where's the vertex? It is on the circle. Inscribed angle, the vertex is on the circle. Okay? So inscribed angle BAC intercepts arc BC. We got the intercepted arcs just like the central angles. And then inscribed angle CAD intercepts what arc? That's right, arc CD. Arc CAD intercepts, I'm sorry, angle CAD intercepts arc CD. All right, so now we can talk angle measures. Oh, just another quick example. Arc BAD, what arc does it intercept? Arc BCD would go, that appears to be a major arc, so we'd use 3 letters for it. So here's the deal with the angle measures. The measure of an inscribed angle is equal to half the measure of its intercepted arc. So in this case right here, I got angle XYZ. It intercepts arc XZ. So 1/2, or this angle is equal to half of the arc. Measure of XYZ equals 1/2 of the arc. I like to move the 1/2 to the other side and make it this, or double the angle equals the arc. So just instead of having 1/2 over here, multiply the angle times 2. 2 times the angle equals the arc. I'm going to do these 2 examples with you, and I'll be done, let you finish the rest. So here we got some angles and we got some arcs. Let's start with X right here. X is an inscribed angle. Its vertex is on the circle. The arc that it intercepts here is what angle measure? 80 degrees. So because it's because it's an inscribed angle, I get to write double the angle equals the arc. 2 times the angle equals the arc. So X equals 40. Okay, whereas Y? Well, Y is this arc over here. That arc is intercepted by this inscribed angle, 55 degrees. Okay, so double the angle equals the arc. 2 times 55 is 110. Okay, Z is this arc right here. It does not have an inscribed angle. There's no chord that intercepts this point right here. But now I know that there's 80, that's 90, that's 110. So all of those together have to add up to equal 360. So 360 minus all of those together gets us to, that's 80 degrees. Okay? All right, one more example. This has an important feature to it. I'm going to start with Y. Well, actually, I'm going to start with what we know. We have this angle measures 35 degrees. What else does that help you to know? I think that's always a good way to start these things. If you don't know, don't see where else to start. That's 35 degrees, so it's inscribed angle, the arc that it intercepts is out here, that's 70 degrees. That double the angle equals the arc. Now, there is another measurement given here. Anybody notice it? What do you call this segment right here? It's a special chord. It goes through the center. That is a diameter. What does a diameter do to a circle? It chops it in half. It creates semicircles. So we actually have 180 degrees going on in here. So this whole arc here is going to equal 180 degrees. If that part's 70, then that arc's 110. This arc right here has to be 110. So 2 times y is going to equal 110. 55 degrees is what y is. Now x is this angle. What does it intercept? The semicircle. Whenever you have an inscribed angle that intercepts a semicircle, that is a right. Okay, I'm not sure exactly what happened there. Hopefully you got my gist about the fact that this semicircle creates all sorts of helpfulness because of 180 degrees with that. All right, double the angle equals the arc, inscribed angles. Okay, you try these. I'm going to give you a couple of hints here in a second, but pause the video before I do. Okay, so here are the hints. There's no hint needed on 1, 2, or 3. I'm gonna give you a hint here. What is this segment? Hopefully you notice that's a semicircle. That's helpful. This is not actually an inscribed angle, but where is the vertex? It's on the circle, so it works the same way. I'll see if you can figure that out from there. In order to figure out what x is, you need to figure out what this arc is. That's all I will say about that one. We'll talk about the rest of these in class. Get some rest. There's the end of the year's coming fast. Goodbye.